We are doing absolute value inequalities, level 2. We're asked to solve the following inequality algebraically. Okay, so let's go ahead and jump right in. So we have the problem 3, absolute value of x plus 5 and absolute value plus 8 greater than or equal to 23. So the technique we use here for these usually is that we'll change this to an equal sign. We solve, that will give us the critical values. Once we have the critical values, we do some test points, and then that'll show us what's true and false. All right, so first, change to an equal sign. 3x plus 5 in absolute value plus 8. This is now equal to 23. Solving, minus 8, 3x plus 5. We're trying to get the absolute value by itself. Equals 15. Divide by 3, divide by 3, and then now we have our x plus 5 in absolute values is equal to 5. All right, so that's our goal, is we had to get the absolute value by itself. Absolute value, when we undo it, it makes two possible equations. So these are OR equations. It could be one or the other in this context. So it's going to be the x plus 5 equals 5. And the other equation is you change the answer into a negative. If there's more to it there, we negate or make opposite the entire other side. So this will now be x plus 5 equals what? Negative 5. All right, we'll solve both of these for x. Minus 5, minus 5. We got x equals 0 on one of this. And then minus 5, and we got x equals negative 10. These are our critical values. All right, the critical values tell us where the important points are. And next is we'll do a number line. So we do a number line now. Show our critical values. Make sure you keep track of which one's which. You don't want to mix them up. We have a 0 and we have a negative 10. Okay, we go back to our original problem, which is this right here, and we notice that there is an equal sign here. That means the critical values have solid. They're included in these problems, and usually if the x is on the greater than side, that's going to be the outsides of here, but we always want to use test points. All right, so once we have the critical values on our number line, then we do test points. Okay, there are 3 regions here that we need to test. So we'll need to test this far left, we'll need to test this middle, and then we need to test this far right. So we pick a value that we think's easy to kind of deal with here. I'll go ahead and say negative 5 right here. And I'm looking at the original, so a negative 5 really helps me on this one. Right here, I'll say negative 11. Just going one more over here. And on here, guess what number I'm going to pick? 1. All right, so I'm trying to pick the easiest values, looking at kind of what happens to x right off the bat. But if you're not sure about why I picked, just make sure you're inside these regions. All right, so it's going to take up some work here. So first, negative 11. Let's go in order. So that's going to imply that 3 times absolute value of negative 11 plus 5 and absolute value plus 8 is greater than or equal to 23. And then I always like to put a question mark next to the equal sign or inequality, because we're asking ourselves, is this true or not? Order of operations, 3 absolute value, that turns into a negative 6, plus 8, greater than or equal to 23, and that's a question mark. This would be 3 times 6, plus 8. Just busy work here, that's fine. 18 greater than, let's try to be careful. Don't erase everything. 3 times 6 is 18 plus 8. greater than or equal to question mark 23. And that's going to be positive 26, greater than or equal to 23, question mark. So the question mark says, is this true or false? Is 26 greater than or equal to 23? That's a true statement. That means we shade that area. So that's a shaded area all on this side, going back to our number line. So it goes all the way to negative infinity. So that's the true area. That's what satisfies this. Those are the answers that work. Negative 5 is going to be next. So negative 5. Plugging that into our original equation. 3, absolute value of negative 5, plus 5 into absolute value plus 8, greater than or equal to 23. And this is a question mark. Now usually, just as an insight, that it's true in one area, false in the other, true in the area. So if it happened to be true in the middle, it would be false, true, false. This one will probably be true, false, true. So it always kind of alternates, usually. All right, but we just want to, at this stage, we're testing points, getting used to the process. 3, we got a 0. That's nice. That's why I picked that one. Plus 8. Absolute value is 0. 0 times 3 is 0. So that's 0 plus 8. 23. And basically, is 8 greater than or equal to 23? Nope, that's false. It's less than. So this is a false area. So here was true. Here was false. We don't shade false. We're shading true. And then the last one, let's just go ahead and check our work with the 1. So now we're testing 1. 3, absolute value of 1 plus 5, end absolute value plus 8, greater than or equal to, questioning it, 23. 3, absolute value of 6 plus 8, questioning if it's greater than or equal to 23. And just as a bit of advice as we're doing these, you cannot pick the critical values. Usually we love to pick 0, but 0 will land us right here. It will be an equal 23 if we do our math right, and that's not going to help us. We're checking the regions. You have to check regions. You cannot check the critical values. So that's an 18 plus 8. Absolute value of 6 is just 6. 6 times 3, 18. And we get 26. These are all questioning. Is 26 greater than 23? That is true. We shade the true area. Go back here. So this is all the area that's getting shaded. Goes all the way to positive infinity. And then that's going to be our final solution. Now in this case, they want it. It's not showing us if they want inequality notation or set notation. Personally, we usually deal with set notation more often. So we'll go ahead and do that. And this is in OR. So notice that we do have OR right here. It can also be union in this context. These two groups are together or in union, but I think I'm probably going to stick to OR and see how that treats us in the final answer. Okay, so what does this mean? Going back to this would be from negative infinity, so we read it left to right. This is how our answer is going to be. Parenthesis, we can't touch negative infinity, that's a comma, and it goes to 10. What kind of parenthesis or bracket or brace do I put here? It's included, so that's a bracket. And as I'm doing this, I really like the idea of union in this context, so I'm going to go ahead and just use union because that's what it seems like to me. That means together. These are all of our answers together. And then we skip this interval here. We start back on 0. We include 0 because it's a filled in circle because it has that equal sign there. And it goes to positive infinity. So this is how our answer is going to look in this context. So it looks like parenthesis bracket. So that's negative infinity to 10. Then I'm using the union, and then it's bracket parenthesis, and we go from 0 to positive infinity. I don't need the positive sign there. And that looks like everything we need. Okay, let's see what we did. Did they want the OR? We'll see. There's the split equation. We got 0 and negative 10. That's all true. We graphed it right. We checked. Okay, so they wanted the OR. I guess that's proper in the absolute value sense. So one or the other would work. Union just means they're both together. To me, not too big of a deal. Everything was correct. We just needed the OR. And like I talked about, I just felt like in this context, union was better, but they like the OR, which is fine. So let's go ahead and make sure we stick with OR from now on. The other type of problem type is the shading inside, and that's just going to be one of these sets. You're going to do exactly the same process, and then you don't have to worry about the or the union. But from now on, when we always have absolute value, we will always be using the or